Hello, class. In this video, I have a case 3 of the Cauchy-Euler method, and this one would be of the complex roots from our auxiliary equation. So, based upon this, and we have our initial conditions attached to it, but currently speaking, before playing along with that portion, we need to form that auxiliary equation by substituting x to the m power for y, and then first and second derivatives. This is going to make 4. Actually, let me write it this way. As we have seen with these other examples, we could factor in x to the m power. But substituting this in and forming our equation, we get 4m times m minus 1 plus 17. And this is supposed to be equal to 0. But we could simplify the inside a bit. X to the m power times 4m squared minus 4m plus 17. And that being equal to 0. So we get two solutions from this, but we need to use the quadratic formula. And they're going to make complex numbers, complex conjugates specifically. 1/2 plus 2y and 1/2 minus 2y, which means alpha here is 1/2 and beta is 2. And we could pop that into our solution. So in our case, this would be x to the 1/2 times c sub 1 times the cosine of 2 times the natural log of x plus c sub 2 times the sine of 2 times the natural log of x. And it so happens that when we apply the math for this y of 1 is equal to -1, we actually find from this that c sub 1 is -1. And likewise, for y prime of 1 being -1/2, we find that c sub 2 is going to be equal to 0. So the full solution for this, full particular solution for this, y is going to be negative x to the 1/2 power times the cosine of 2 times the natural log of x. And this graph here on the right just shows that this is oscillatory and it's unbounded. As we keep increasing this without bound, the function is going to keep increasing. So it does not approach any specific number. So let me know if you have any questions or concerns. Thank you.